Okay, today we're going to be talking about exponential functions. This is something new. Okay, it's like when we were talking about linear functions. Those are lines. Well, this is what exponential functions look like. Look at the graphs. Okay, if it's going up, that is called a growth. And I'm going to show you right now in a little bit. And then if it's going down, that is called a decay. Okay, so the equation that you guys are going to be using today for exponential functions, write this down, is y equals a parentheses b close parentheses to the power of x. That's a little exponent. And then we can use plus c, plus or minus c. Okay, same thing here. Write it again. A parentheses b close parentheses to the power of x plus or minus a c. That's the equation we're going to be using. If the b is greater than 1, so if this happens, if b is greater than 1, that means that number right there with the exponent is greater than 1, then it's going to be an exponential growth. Okay, and it's going to be increasing. So this one right here is increasing. Look, it's going up. So that's a growth. Also, this is the b. It's greater than 1, so it's a growth. So circle growth for problem number 1. If it's going up, it's going to be a growth. If the b is less than 1, so if this number with the exponent is smaller than 1, then it's going to be an exponential decay. And it will be decreasing. Like problem number 2. I'll go back up in a little bit. But problem number 2, this is the b, right? The one with the exponent. It's less than 1, and the graph is decreasing. It's going down. So that's called a decay. This is a growth up here, number 1. This is a decay. So circle decay for problem number 2. Okay, another thing that we're going to be talking about is also the asymptote. Okay, and I'll draw it in a little bit, but an asymptote is an imaginary line. It's an imaginary line which the graph approaches, and it's always going to be your c. Okay, your asymptote will be your c, plus or minus c. That is your asymptote. So again, asymptote is an imaginary line. So if I go down here, I'm going to erase these lines because they messed up when I moved the graphs. So this line starts right here. Okay, and it goes up, 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 up. But it never goes past this imaginary line right here. There's an imaginary line. It's like a force field. It's never going to go down lower than that. It's just going to kind of go like this. Okay, so the asymptote for this one right here, plus 0, my asymptote is y equals 0. Because there is none. There's no number, right? So that's my 0. And here it is right here. I showed it to you. It's an imaginary line at y equals 0. Okay. Another thing that's really easy to figure out is the y-intercept. Y-intercept, remember, is where it crosses the y-axis. This line right here. It crosses it at this number. What is this number? 1. So my y-intercept is at 0, 1. So those are some easy things that you can remember when I ask you for key features. Another really easy thing, please know that the domain of exponential functions is always all real numbers. Always. All real numbers. So when? Always. Domain is always all real numbers. So what's the domain here? All real numbers. Problem number 2, the domain is all real numbers. Why? Because it's going to keep going to the left forever and to the right forever. What about number 5? What's the domain here? All real numbers. It's going to go to the left forever, to the right forever. What about number 4? What's the domain? All real numbers. What about number 3? What's the domain? All real numbers. All real numbers. Always. All real numbers. Domain right here. All real numbers. Because it's going to keep going to the left and to the right forever and ever and ever and ever. The one that you're going to have a little bit of a problem with is going to be the range. Range is from the bottom to the top, right? So it's always going to start at the asymptote. So whatever the asymptote is, that's what your range is going to be. And this one is going up. So it starts at 0 and it goes up. So it's all real numbers greater than 0. Okay, it starts at the asymptote. Then you have to figure out, is it going up or is it going below? Is it going above the asymptote or below the asymptote? So let's do problem number 2. What's the domain for problem number 2? All real numbers. Okay, so what is the y-intercept for this one, for problem number 2? The y-intercept. So I'm looking on the y-axis, right? It's where it crosses the y-axis, and it's at 1. So my y-intercept is at 0, 1. What is the asymptote? Asymptote is your c, remember? What is my c here? 0 plus 0. So my c is 0. So my y-asymptote is at y equals 0. Okay? That means there's an imaginary line right here that it's never going to cross. Okay? Imaginary line, like a force field. Think of Star Wars. Then, the range. The range starts right here at 0 and it's going up, right? So it's from 0 all the way up. So it's y is greater than 0. All the numbers y greater than 0. All right, let's do a few more. Go to problem 3. Problem 3, what is my asymptote here? -1. It's my c, right? Asymptote is your c. So it's -1 because it goes right here. Look, there's an imaginary line right there where it stops. So it's y equals -1. Is it a growth or a decay? Growth is going up. Okay, from left to right. Izquierda a derecha is going up. It's a growth. My b is greater than 1. So it's a growth. What is my y-intercept? 0. It's right here, look. It crosses the y-axis at 0. So it's 0, 0. And what is my range? What is the lowest point that it goes on the range? Not 0. -1, and then it goes all the way up. So it's y greater than -1. Okay, it's always going to be at the asymptote. So if the asymptote is -1, then the range is going to have -1. But you have to figure out, is it above going up or is it below going down? Okay. Problem number 4. What's my asymptote here? My asymptote. +4. So y equals 4. Why? Because on my graph, my imaginary line is at 4. Okay? What's my y-intercept? 5. My y-intercept is at 5, so 0, 5. And what is the range? What is the range? Starts at 4, right? Right here. And it's going up. So it's y greater than 4. It cannot equal to it because the asymptote is never going to touch the asymptote. Ever, 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 ever. And then problem 5. Is this a growth or a decay? This is my A. This is my B. My B is greater than 1. It's going up. Look, it's going up. So it's a growth. What's my domain? All real numbers. What is my asymptote? What is my asymptote? 0 plus 0, right? It's my C. So y equals 0. What is my y-intercept? Let me erase this part so you can see it. My y-intercept is right here. It's this one right here, 1/4. Okay, so it's 0, 1/4. You can also, in Desmos, you can click on it and it'll show you exactly what it is. So you can type this equation in Desmos and you can click on it. Let's go do that right now. Let's go put it in Desmos. Oh, I can't. Where's my... Y equals, everybody's typing this. Y equals 1/4, parentheses, 2, close parentheses, to the power of x. Okay, here's my y-intercept. You see the point? When you click on it, it's 0, 0.25, which is 0, 1/4. If I type 0.25 and click my fraction, it will tell me that it's 1/4. Okay, so that's how you would do it on the test, on the quizzes. Is this recording or not recording? And then the last one that we're going to do is the range. I know that my range starts at the asymptote, right? Right here, the imaginary line. And it's going up. Here's my asymptote. And the graph is going up. So it's y greater than 0. Okay? You're going to do a quizzes. I'm going to type the code on the board for you to get on it and do those problems. It's going to be just like this. If you need to graph the equation, I just showed you how to graph the equation. If you were not paying attention, then go back, rewind it a little bit so you can see how to graph the equation.